May 12, 1943. 2300 hours. The waters of the Sicily Channel lay black and restless under a moonless sky, carrying the scent of diesel fuel and salt spray across the Mediterranean's ancient hunting grounds. Aboard the destroyer, USS Wolsey, Sonneman First Class Thomas Keller pressed his headphones tight against his ears, filtering the ocean's symphony for the one sound that meant death or glory. The hydrophones captured everything: the distant thrum of Allied escort engines, the whisper of waves against steel hulls, the metallic ping of active sonar sweeping the depths like an invisible lighthouse beam. But somewhere in that acoustic maze, Keller knew, lurked the last desperate gambit of the Africa Corps, a steel coffin carrying the final remnants of Rommel's shattered dream, racing through the darkness toward Sicily and sanctuary. The bridge of the Wolsey hummed with tension, thick as the Mediterranean fog. Commander James Morrison stood motionless at the navigation table, his weathered fingers tracing the penciled patrol routes that divided the narrow waters between Tunisia and Italy into a grid of mathematical certainty. Each square represented a killing field, where American destroyers, British frigates, and Royal Navy corvettes maintained their invisible wall of steel and explosive ordnance. The air tasted of coffee grown cold hours ago and the metallic bite of gun oil from the 5-inch guns that stood ready in their turrets. Below decks, the engineering spaces thrummed with the rhythm of turbines that had carried this ship from the Atlantic convoys through the invasion beaches of North Africa to this moment, the final hunt of Operation Retribution. The water temperature read 58 degrees Fahrenheit. The barometric pressure was falling. And in the sonar shack, Thomas Keller was about to hear the signature that would end the last submarine escape route from the collapsing North African campaign. 3 days earlier, in the bombed-out harbor of Tunis, Captain Lieutenant Heinrich Schaefer had stood on the conning tower of U-377, watching American destroyers patrol the distant horizon like lazy shepherds tending mechanical flocks. The contempt in his voice carried across the oil-slicked water to his assembled crew. These Americans, he declared, were amateurs playing at naval warfare in waters that belonged to the Kriegsmarine. They moved in predictable patterns, their sonar sweeps too regular, their depth charge attacks too conservative. The Mediterranean was not the Atlantic, where U-boats had learned to fear the wolf packs of Allied escorts. Here, in these ancient waters where Phoenician galleys had once ruled, German submarines had operated with impunity for 3 years, sinking Allied merchantmen at will and evacuating key personnel from the collapsing African front. Oberst Wilhelm Meyer of the Afrika Korps intelligence staff had laughed openly at the American patrol reports intercepted by German communications specialists. The destroyer captains, he noted with aristocratic disdain, communicated their positions in clear radio transmissions, as if broadcasting their locations to any German submarine commander with a functioning radio receiver. Their anti-submarine tactics, Meyer observed, followed textbook procedures developed in the North Atlantic: rigid depth charge patterns, predictable search geometries, and systematic grid sweeps that any competent U-boat commander could evade with elementary maneuvering. The Americans, Meyer concluded, approached submarine hunting like engineers solving a mechanical problem, lacking the intuitive cunning that separated true naval warriors from mere technicians operating expensive machinery. The German naval staff in Rome had distributed tactical analyses demonstrating American inadequacy in submarine warfare. Their destroyers, according to intercepted intelligence reports, suffered from mechanical reliability problems that forced frequent returns to port. Their sonar operators lacked the acoustic expertise developed by Royal Navy veterans of the Battle of the Atlantic. Most critically, their depth charge attacks showed insufficient aggression. American commanders, the analysis noted, preferred to maintain safe distances rather than closing to point-blank range where submarine kills became mathematical certainties. These Americans, the report concluded, approached naval combat with the cautious mentality of accountants rather than the ruthless efficiency of professional killers. In the narrow waters of the Sicily Channel, where German submarines had evacuated thousands of Wehrmacht personnel throughout the North African campaign, this American timidity would prove fatal to their mission of maintaining an airtight blockade. Operation Retribution represented the largest concentrated anti-submarine operation in Mediterranean history, orchestrated by Supreme Allied Commander Dwight Eisenhower, with the surgical precision of an industrial engineer and the moral authority of a democratic crusade. The strategic objective transcended mere tactical success. This operation would demonstrate whether American naval power, built on the foundation of Detroit assembly lines and Pittsburgh steel mills, could match the submarine expertise that German officers had refined through 4 years of Atlantic warfare. Every Allied vessel participating in the blockade carried the weight of national industrial capacity. Destroyers whose hulls contained steel from Pennsylvania blast furnaces, sonar equipment manufactured in Massachusetts electronics plants, and depth charges filled with explosive compounds synthesized in Texas chemical refineries. The USS Woolsey exemplified this marriage of American industrial might with tactical innovation. Commissioned in January 1943 at the Federal Shipbuilding and Dry Dock Company in New Jersey, she displaced 2,050 tons and stretched 376 feet from bow to stern, powered by General Electric turbines generating 60,000 shaft horsepower through Babcock and Wilcox boilers that could push her through heavy seas at 37 knots. Her primary armament consisted of 4 5-inch dual-purpose guns manufactured by the Naval Gun Factory in Washington, D.C., each capable of firing 15 rounds per minute with mathematical precision guided by Mach 37 fire control computers that represented the cutting edge of analog computational technology. But the Woolsey's true weapon was her sonar suite, the QGB underwater sound detection system that transformed submarine hunting from an art of intuition into a science of acoustic analysis. The QGB array, manufactured by Western Electric using technology developed at Bell Laboratories, could detect submarine signatures at ranges exceeding 4,000 yards under optimal conditions. The system processed underwater sound waves through electronic filters that separated mechanical noise from biological interference, displaying target information on cathode ray oscilloscopes that revealed submarine movements with unprecedented clarity. Each ping transmitted by the QGB system generated 24 kilohertz of acoustic energy, creating sound waves that penetrated the Mediterranean's thermoclines and reflected off submarine hulls with the reliability of lighthouse beams cutting through fog. The tactical doctrine governing American anti-submarine operations reflected lessons learned through bitter experience in the North Atlantic, where German U-boats had sunk over 3,500 Allied merchant vessels during the first 4 years of war. American destroyer commanders had studied every engagement report, analyzing successful attacks to identify the factors that separated effective submarine hunters from vessels that merely patrolled empty water. The data revealed uncomfortable truths about submarine warfare. Most depth charge attacks failed because commanders attacked too soon, before establishing definitive contact, or too late, after submarines had evaded detection through emergency maneuvers. Successful attacks required patience to confirm target signatures, aggression to maintain contact despite enemy countermeasures, and mathematical precision to calculate attack geometries that accounted for target speed, depth, and probable evasion patterns. Commander Morrison embodied this synthesis of academic analysis and combat experience.
A 1934 graduate of the Naval Academy who had served as a destroyer executive during the early Atlantic convoy battles, he approached submarine hunting with the methodical intensity of a research scientist, combined with the competitive instincts of a professional athlete.
His tactical philosophy emphasized systematic detection procedures followed by relentless pursuit. Once the Woolsey achieved sonar contact with a submarine, Morrison would maintain that contact regardless of fuel consumption, ammunition expenditure, or crew fatigue until the target was destroyed or captured. This approach reflected broader American military doctrine that leveraged industrial superiority to sustain operations longer than enemy forces could maintain their resistance. The crew of 329 officers and enlisted men aboard the Woolsey represented a cross-section of American industrial society transformed into naval warriors through intensive training programs that compressed years of seamanship experience into months of concentrated instruction. Sonarman Keller, a former radio technician from Ohio who had learned acoustic analysis at the Navy's anti-submarine warfare school in Key West, could distinguish between the cavitation patterns of different submarine types by analyzing the harmonic signatures generated by their propeller systems. Fire control technician Second Class Rodriguez, who had operated precision machinery in a California aircraft factory before joining the Navy, maintained the electronic computers that calculated firing solutions for the ship's main battery. Torpedo Man's mate, First Class Johnson, a former auto mechanic from Detroit, supervise the depth charge crews with the systematic efficiency he had previously applied to automotive assembly lines. This fusion of civilian technical expertise with military discipline created a fighting effectiveness that German submarine commanders consistently underestimated. American destroyer crews approached anti-submarine warfare with the problem-solving mentality of engineers rather than the heroic traditions of European naval officers. They analyzed submarine tactics as technical challenges to be solved through systematic application of superior equipment and coordinated teamwork. Where German U-boat crews relied on individual initiative and tactical improvisation, American destroyer crews implemented standardized procedures developed through exhaustive analysis of combat data and refined through repetitive training exercises that automated their responses to tactical situations. The broader strategic context of Operation Retribution reflected the inexorable momentum of American industrial mobilization reaching full combat effectiveness. By May 1943, American shipyards were launching destroyers faster than German yards could construct submarines. The Kaiser shipbuilding plants in California had reduced destroyer construction time from 18 months to 6 months through application of assembly line techniques that Henry Ford had pioneered in automobile manufacturing. Meanwhile, American electronics manufacturers were producing sonar equipment, radar systems, and fire control computers in quantities that exceeded the combined production capacity of all Axis nations. This industrial avalanche created tactical advantages that transcended individual courage or professional skill. American naval forces could afford to make mistakes, learn from failures, and return to combat with improved equipment and tactics, while German forces faced the mathematical certainty of attrition warfare against an enemy whose production capacity exceeded their ability to inflict losses. The Sicily Channel itself represented a geographical choke point where American industrial superiority could achieve decisive tactical results. Measuring only 90 miles at its narrowest point, the channel created a natural funnel where submarines attempting to evacuate German personnel from North Africa faced concentrated Allied naval forces operating with mutual support and overlapping detection coverage. Unlike the vast expanses of the Atlantic Ocean, where submarines could evade detection through speed and stealth, the confined waters of the Sicily Channel forced submarine commanders to traverse predetermined routes under constant surveillance by Allied patrol aircraft and surface vessels. As the final hours of May 12th approached, the tactical situation crystallized into a mathematical problem of detection probability and escape geometry. Intelligence reports confirmed that at least 3 German submarines remained in North African ports, carrying high-value personnel including technical specialists, intelligence officers, and senior military commanders whose capture would provide invaluable information about German defensive preparations in southern Europe. These submarines represented the last organized evacuation effort from the collapsed North African front. Their destruction or capture would symbolize the complete Allied victory in the Mediterranean theater and demonstrate American naval competence in waters traditionally dominated by European maritime powers. The weather conditions on the night of May 12th created optimal circumstances for submarine detection. The Mediterranean's characteristic calm weather minimized surface interference with sonar systems, while the absence of commercial shipping traffic eliminated acoustic clutter that could mask submarine signatures. Water temperature profiles showed minimal thermoclines that might deflect sonar waves, and tidal conditions produced predictable current patterns that restricted submarine maneuvering options. These environmental factors, combined with the concentrated Allied patrol coverage, created what naval tacticians termed a detection cage, a situation where submarine evasion required not merely skill and luck, but mathematical impossibility, given the overlapping sensor coverage and limited escape routes. At 23:17 hours, Sonarman Keller detected the first faint signature that would transform Operation Retribution from a strategic concept into tactical reality. The initial contact appeared as a subtle variation in the ambient noise spectrum, a rhythmic pulse barely distinguishable from the random acoustic patterns generated by marine life and ocean turbulence. Keller's trained ear, however, recognized the mechanical regularity that distinguished artificial sounds from natural phenomena. The signature exhibited the characteristic frequency components of diesel engine vibration transmitted through a submarine hull, modulated by the acoustic effects of propeller cavitation and hull flexing under pressure. The detection process unfolded with the methodical precision that American naval training emphasized over intuitive recognition. Keller immediately notified the bridge through the sound-powered telephone system that connected all battle stations without dependence on electrical power that enemy action might disrupt. Commander Morrison responded with practiced efficiency, ordering the ship to general quarters while maintaining course and speed to avoid alerting potential submarine contacts to their detection. The crew reached battle stations in 4 minutes and 37 seconds, a response time that reflected months of intensive drilling designed to automate combat preparations under the stress of actual engagement. The sonar contact developed clarity and definition as the Woolsey adjusted course to optimize acoustic reception. The target signature revealed characteristics consistent with a German-type 7C submarine, the most common U-boat variant operating in the Mediterranean theater. The acoustic profile indicated a displacement of approximately 769 tons surfaced, with diesel engines generating 2,800 horsepower for surface operations and electric motors producing 750 horsepower for submerged movement. The propeller signature suggested a twin-screw configuration rotating at approximately 180 revolutions per minute, creating cavitation patterns that experienced sonar operators could identify with reasonable confidence despite the complex acoustic environment of shallow Mediterranean waters. But this initial success quickly revealed the harsh realities of anti-submarine warfare that separated theoretical training from combat effectiveness. The submarine contact, upon detecting the approaching destroyer through its own passive sonar systems, immediately implemented evasive maneuvers that demonstrated the tactical sophistication German submarine commanders had developed through 4 years of Atlantic combat operations. The U-boat executed a crash dive to maximum safe depth, reduced engine power to minimize acoustic signature, and initiated a series of course changes designed to confuse Allied tracking systems through rapid directional shifts that exceeded the response time of mechanical fire control computers. The USS Woolsey's first depth charge attack exemplified the challenges facing American naval forces transitioning from theoretical knowledge to combat application. Commander Morrison ordered the attack based on projected target position, calculated from the last confirmed sonar bearing, but the submarine's evasive maneuvers had carried it beyond the kill radius of the depth charge pattern. The 24 Mark 7 depth charges detonated in a sequence timed to create overlapping shock waves. But the submarine had anticipated this standard American tactic and positioned itself outside the lethal blast zone through superior underwater maneuverability. The failure of the initial attack created a tactical crisis that tested American doctrine under combat stress. The depth charge explosions had temporarily degraded sonar effectiveness through reverberation effects that masked submarine signatures, while simultaneously alerting the submarine to the precise location and capabilities of its pursuers. German submarine commanders had learned to exploit this brief acoustic blindness by implementing emergency course changes that could break contact entirely if pursuing vessels failed to maintain accurate position estimates during the post-attack confusion. Sonarman Keller experienced the psychological impact of combat failure as the familiar acoustic signatures disappeared into the chaotic echoes of exploding depth charges. The methodical training procedures that had seemed so reliable during peacetime exercises proved inadequate for the complex realities of submarine evasion tactics developed through desperate survival experience. The electronic displays that had provided clear target information during training scenarios now showed only the random noise patterns of disturbed water and mechanical debris, leaving the crew to question whether their target had been destroyed, escaped, or merely relocated beyond detection range. Commander Morrison faced the fundamental decision that separated successful submarine hunters from commanders who lost contact through indecision or premature abandonment of pursuit. The tactical manuals provided clear guidance for this situation: maintain systematic search patterns while awaiting sonar clarity, expand search area to account for probable target movement, and coordinate with adjacent vessels to establish contact reacquisition. But the manuals could not account for the psychological pressure of potential failure in the first major anti-submarine engagement of Operation Retribution, where American naval competence was being tested against German submarine expertise in waters that had witnessed 3 years of Axis naval dominance. The decision to continue the hunt reflected the industrial confidence that distinguished American naval doctrine from the resource-conscious tactics employed by materially inferior forces. The Woolsey possessed sufficient fuel capacity for extended operations, adequate ammunition reserves for multiple engagement cycles, and crew endurance, enhanced by superior logistics support that maintained combat effectiveness through sustained operations. This industrial advantage enabled tactical patience, the ability to maintain pursuit through temporary setbacks and systematic search procedures that gradually reduced the submarine's evasion options through persistent pressure and overlapping patrol coverage. As the acoustic effects of the initial depth charge attack gradually subsided, sonarman Keller methodically recalibrated his equipment to restore optimal detection sensitivity. The QGB sonar system incorporated automatic gain control circuits that compensated for temporary acoustic interference, gradually increasing receiver sensitivity as background noise levels returned to baseline conditions. This technological advantage, developed through American electronics industry innovations, enabled faster contact reacquisition than German submarines anticipated based on their experience with British sonar systems that required manual adjustment following depth charge attacks. The submarine contact reappeared at bearing 285 degrees, range approximately 2,800 yards, moving at estimated speed of 8 knots on a northwesterly course toward the Italian coastline. The acoustic signature had changed subtly. The propeller cavitation patterns indicated reduced engine power and modified propeller pitch consistent with maximum stealth configuration. The German submarine commander was employing classic evasion tactics, sacrificing speed for reduced acoustic signature while attempting to reach the complex underwater terrain near Sicily, where rocky sea floor conditions would degrade sonar effectiveness and provide concealment opportunities. Commander Morrison's tactical response demonstrated the systematic approach that American naval training emphasized over inspirational leadership or heroic individual initiative. Rather than immediately attacking the reacquired contact, he ordered a deliberate approach designed to confirm target identification and establish optimal attack geometry. The Woolsey adjusted course to parallel the submarine's probable track while maintaining sonar contact through precise navigation that kept the target within optimal detection range without closing to distances where the submarine's own sonar systems could achieve reciprocal detection of the approaching destroyer. This patient stalking phase revealed the technological advantages that American naval forces could leverage through superior industrial production and systematic crew training. The Woolsey's radar systems provided precise navigation reference that enabled accurate dead reckoning during sonar tracking operations, while radio communications with adjacent Allied vessels created overlapping surveillance coverage that prevented submarine escape through coordinated patrol gaps. The fire control computers continuously calculated attack solutions based on current target data, automatically updating depth charge release points and timing sequences as tactical conditions evolved. The submarine commander, Captain Lieutenant Heinrich Schaefer, commanded U-377, a Type SIP-8C submarine that had operated successfully in Mediterranean waters for 14 months before being assigned to the final evacuation mission from North Africa. His vessel carried 39 crew members plus 16 German military personnel, including intelligence specialists, technical advisors, and staff officers whose knowledge of German defensive preparations made their capture or elimination a high priority for Allied intelligence services. The submarine's fuel reserves limited operational endurance to approximately 60 hours at current consumption rates, creating time pressure that favored persistent Allied pursuit over submarine evasion tactics. The tactical situation evolved into a deadly mathematics problem where industrial capacity competed against tactical expertise in an environment that favored systematic persistence over individual brilliance. The Woolsey possessed the fuel capacity, ammunition reserves, and crew endurance to maintain pursuit indefinitely, while U-377 faced the mathematical certainty of fuel exhaustion if unable to break contact and reach safe harbor within a predetermined time window. This resource imbalance reflected the broader strategic situation where American industrial mobilization had created tactical advantages that exceeded German ability to compensate through superior individual training or tactical innovation. As the pursuit continued through the early morning hours of May 13th, the psychological effects of sustained pressure began affecting both crews in ways that training scenarios could not replicate. Aboard the Woolsey, the crew maintained battle stations with the mechanical efficiency that American military doctrine emphasized, but the prolonged tension of potential combat created fatigue patterns that threatened optimal performance during critical engagement phases. Sonarman Keller reported increasing difficulty distinguishing between actual submarine signatures and acoustic phantoms generated by equipment strain and operator fatigue, requiring systematic verification procedures that slowed contact confirmation and increased the risk of losing the target during critical tactical moments. Inside U-377, the effects of prolonged submersion under combat conditions created physiological stresses that German submarine training had addressed through crew selection and conditioning programs, but which nonetheless degraded operational effectiveness through cumulative exhaustion and psychological pressure. The submarine's air regeneration systems, designed for normal patrol operations, struggled to maintain atmospheric quality during extended deep submersion, with an overcrowded crew complement that included non-naval personnel unfamiliar with submarine emergency procedures. Carbon dioxide levels approached dangerous concentrations, requiring periodic shallow depth operations that increased detection vulnerability. The technological dimension of the pursuit revealed fundamental differences between American and German approaches to naval warfare that reflected broader industrial and social philosophies. American sonar systems emphasized electronic processing and automated analysis, designed to reduce operator fatigue and maintain consistent performance during extended operations. German submarine detection equipment relied more heavily on operator skill and experience, creating superior short-term performance, but reduced effectiveness during prolonged engagements that exceeded human physiological limits. Commander Morrison's tactical patience reflected American naval doctrine that leveraged industrial superiority through sustained operations designed to exhaust enemy resources and force tactical mistakes through cumulative pressure. Rather than seeking decisive engagement through heroic attacks that risked operational failure, Morrison maintained methodical pursuit that gradually reduced the submarine's evasion options while preserving his own vessel's combat effectiveness through systematic procedures that distributed stress across multiple crew members and automated systems. The pursuit trajectory carried both vessels through waters that had witnessed 3 years of naval warfare between Axis and Allied forces, creating underwater hazards from sunken vessels and unexploded ordnance that complicated navigation and tactical maneuvering for both submarine and destroyer crews. The Mediterranean seafloor contained wreckage from hundreds of merchant vessels, naval combatants, and aircraft that created acoustic interference patterns and physical obstacles requiring constant navigation adjustments. These environmental factors favored the submarine, whose shallow draft and superior underwater maneuverability enabled navigation through underwater obstacle fields that forced surface vessels to maintain safer but more predictable courses. At 0347 hours, the tactical situation reached critical decision point, when U-377's diesel engines began showing signs of mechanical stress from prolonged operation under combat conditions. The acoustic signature detected by Woolsey's sonar indicated irregular engine timing and increased vibration levels, consistent with mechanical problems that would force the submarine to choose between continued evasion at reduced capability or emergency surface procedures that would expose the vessel to devastating gunfire from the destroyer's 5-inch battery. This mechanical crisis reflected the resource constraints facing German naval forces operating aging equipment under extreme conditions without adequate maintenance support or replacement parts. Captain Lieutenant Schaefer faced the tactical decision that separated professional naval officers from commanders paralyzed by impossible choices. His submarine's mechanical condition precluded continued deep submersion, while surfacing within gun range of an American destroyer represented certain destruction for his vessel and probable death for his crew. The intelligence officers aboard his submarine carried information about German coastal defenses that could not be allowed to fall into Allied hands, creating moral obligations that transcended personal survival considerations. The German submarine commander's tactical analysis revealed the mathematical hopelessness of his situation with brutal clarity. His vessel's maximum surface speed of 17 knots could not outrun the destroyer's 37-knot capability, while submerged operations were limited by mechanical problems and depleted battery reserves that provided less than 4 hours of underwater movement at minimum speed. The nearest German-controlled harbor lay 180 nautical miles distant through waters patrolled by concentrated Allied naval and air forces, creating escape probabilities that approached statistical impossibility even under optimal conditions. But U-377's desperate situation also created tactical opportunities that experienced submarine commanders could exploit through calculated risk-taking and superior knowledge of underwater terrain features. The seafloor topography near Sicily included underwater ridges and thermal layers that could mask submarine signatures from surface-based sonar systems, while coastal shipping lanes provided potential concealment among neutral merchant vessels that international law prohibited Allied forces from attacking without verification of hostile intent. Schaefer's decision to attempt escape through the treacherous waters near Cape Passero demonstrated the tactical desperation and professional competence that characterized German submarine operations during the final phases of the Mediterranean campaign. This course change brought U-377 into shallow waters, where underwater maneuvering became extremely hazardous, but where complex acoustic conditions created detection difficulties for pursuing surface vessels. The submarine's reduced draft enabled navigation through areas where the Wolsey's deeper keel created grounding risks that limited pursuit options. The tactical pursuit entered its most dangerous phase, as both vessels approached the complex underwater terrain that had claimed numerous submarines and surface ships throughout the Mediterranean campaign. These waters contained magnetic anomalies from iron ore deposits that interfered with compass navigation, creating navigation hazards for vessels dependent on precise positioning for tactical effectiveness. The acoustic environment near rocky coastlines created echo patterns that masked genuine submarine signatures, while generating false contacts that could misdirect pursuing forces during critical engagement phases. Commander Morrison's response to these changing tactical conditions demonstrated the systematic training that enabled American naval officers to maintain effectiveness during complex operational situations. Rather than allowing environmental challenges to degrade pursuit effectiveness, Morrison coordinated with shore-based radar stations and patrol aircraft to maintain contact through multiple sensor systems that compensated for individual system limitations. This integrated approach reflected American military doctrine that emphasized technological integration and systematic procedures over individual tactical brilliance. The coordination between surface, air, and shore-based assets created surveillance coverage that German submarine commanders had not previously encountered in Mediterranean waters. Royal Air Force Coastal Command aircraft equipped with ASV Mark III radar provided aerial surveillance that could detect surface submarines at ranges exceeding 20 miles, while direction-finding stations monitored German radio communications to track submarine positions through electronic intelligence gathering. This comprehensive surveillance network created tactical conditions that made submarine evasion extremely difficult, even for experienced commanders operating in familiar waters. U-377's final tactical options narrowed to desperate expedients as mechanical problems and fuel depletion eliminated conventional evasion possibilities. Schaefer ordered the submarine to minimum depth in an attempt to reach shallow water, where the destroyer's depth charges would be less effective due to proximity to the sea floor. But this maneuver brought the submarine within range of the Wolsey's forward-firing Hedgehog anti-submarine mortars that could attack targets at depths where conventional depth charges risked surface vessel damage from blast effects. The Hedgehog system represented American innovation in anti-submarine warfare that addressed tactical problems through technological solutions rather than modifications to existing equipment. Unlike depth charges that detonated at predetermined depths regardless of target proximity, Hedgehog projectiles incorporated contact fuses that exploded only upon striking submarine hulls, creating more lethal attacks while eliminating the acoustic interference that conventional depth charges generated during attack sequences. This technological advantage enabled American destroyer crews to maintain sonar contact throughout attack procedures, significantly improving attack accuracy and reducing the time required between detection and engagement. At 0521 hours, sonar contact suddenly intensified as U-377 was forced to increase engine power due to approaching shallow water that required precise navigation to avoid grounding. The increased acoustic signature provided sonarman Keller with definitive target identification and precise bearing information that enabled Commander Morrison to order the final attack with mathematical certainty of target location and movement parameters. The fire control solution incorporated current speed and heading data, water depth measurements, and probable evasion patterns based on submarine performance characteristics and tactical constraints imposed by the underwater terrain. The Woolsey's Hedgehog attack launched 24 contact-fused projectiles in a pattern designed to cover the submarine's probable position, allowing for evasive maneuvering during the projectile flight time. The mathematical precision of American fire control systems, developed through extensive analysis of previous anti-submarine engagements, created attack geometries that accounted for target movement uncertainty and weapon dispersion patterns to maximize kill probability while minimizing ammunition consumption and attack duration. The tactical climax occurred in the pre-dawn darkness of May 13th, as multiple Hedgehog projectiles achieved direct contact with U-377's pressure hull, creating catastrophic structural damage that eliminated the submarine's ability to maintain depth control or watertight integrity. The contact explosions, each containing 35 pounds of Torpex high explosive, generated shock waves that exceeded the submarine's structural design limits and caused immediate flooding through multiple hull breaches that overwhelmed the vessel's damage control capabilities. Captain Lieutenant Schaefer's final command decision reflected the professional honor and tactical reality that governed submarine warfare during desperate situations. Rather than allowing his crew to die through prolonged flooding and suffocation, he ordered emergency surface procedures that brought U-377 to the surface within visual range of the American destroyer. The submarine emerged from the Mediterranean waters trailing oil and exhibiting obvious battle damage, but with sufficient structural integrity to enable crew evacuation before final sinking. The surrender of U-377 occurred with the formal dignity that characterized naval warfare between professional military forces, despite the ideological hatred that motivated the broader conflict. Commander Morrison ordered ceasefire as soon as the submarine's surrender signal was recognized, and immediately began rescue operations to recover German crew members and passengers from the damaged submarine before final hull failure sent the vessel to the bottom. This professional courtesy reflected American naval traditions that distinguished between military necessity and personal vengeance, treating captured enemies as defeated professionals rather than ideological criminals. The intelligence value of the captured German personnel exceeded the tactical significance of sinking a single submarine, as the officers and technical specialists aboard U-377 possessed detailed knowledge of German defensive preparations throughout southern Europe that proved invaluable during subsequent Allied invasion planning. The interrogation of these prisoners provided confirmation of German troop dispositions, coastal fortification details, and supply logistics that enabled more effective targeting during the upcoming invasion of Sicily. This intelligence windfall demonstrated how tactical success in individual engagements could generate strategic advantages that exceeded the immediate military value of destroyed enemy equipment. The broader implications of U-377's destruction extended beyond the immediate tactical results to encompass fundamental questions about naval warfare effectiveness and industrial capacity that would influence American military doctrine throughout the remaining years of World War II. The successful pursuit and destruction of an experienced German submarine crew by an American destroyer represented validation of American naval training methods, technological innovation, and industrial production capabilities that had been questioned by European military experts who doubted American ability to transition from peacetime manufacturing to effective military operations. The systematic approach that enabled the Woolsey's success reflected American military philosophy that emphasized technological solutions and methodical procedures over tactical inspiration and individual heroism. This approach proved particularly effective in anti-submarine warfare, where success required sustained operations that exceeded human endurance limits and technological complexity that demanded systematic training rather than intuitive skill development. American naval forces demonstrated that industrial capacity and systematic organization could overcome tactical expertise developed through prolonged combat experience. The destruction of U-377 marked the effective end of German submarine evacuation operations from North Africa, as subsequent intelligence reports confirmed that this vessel carried the last organized group of high-value personnel attempting to escape Allied capture. The successful completion of Operation Retribution demonstrated American naval competence in Mediterranean waters that had been dominated by Axis forces for 3 years, establishing American credibility as a major naval power capable of effective operations in any maritime theater. The tactical lessons learned from this engagement influenced American anti-submarine doctrine throughout the Pacific Campaign, where similar systematic approaches proved effective against Japanese submarine forces that employed different tactical methods but faced similar resource constraints when confronted by superior American industrial capacity and technological integration. The Mediterranean experience validated American confidence in technological solutions and systematic procedures that could be applied successfully against any enemy that lacked equivalent industrial support.
The crew of the USS Woolsey received official recognition for their professional competence in this engagement, but the broader significance of their success lay in demonstrating that American naval forces had achieved operational maturity that enabled effective competition with experienced European naval powers.
The United States Navy had successfully transitioned from a peacetime force dependent on British naval expertise to an independent military organization capable of innovative tactics and sustained operations in any maritime environment. The wreckage of U-377 remains on the Mediterranean sea floor as a monument to the industrial transformation that enabled American naval forces to achieve global effectiveness through systematic application of technological innovation and resource mobilization. The submarine's destruction represented not merely a tactical victory, but confirmation that American society possessed the organizational capability and industrial capacity to sustain global military operations that would ultimately determine the outcome of World War II through superior logistics and systematic operational excellence. The final radio transmission from the Woolsey reported the successful completion of her assigned mission with characteristic American understatement. Enemy submarine destroyed. Survivors recovered, resuming patrol. This laconic communication style reflected the professional confidence that American naval forces had developed through successful operational experience, treating tactical victories as routine accomplishments rather than extraordinary achievements worthy of extended celebration. As dawn broke over the Sicily Channel on May 13, 1943, the Mediterranean had become an American lake where German submarines could no longer operate with impunity against Allied shipping lanes and military operations. The systematic effectiveness of Operation Retribution had eliminated the last vestige of Axis naval resistance in waters that would soon serve as the highway for Allied invasion forces moving against the European mainland. The industrial might of American shipbuilding and the methodical competence of American naval crews had transformed the strategic balance in Mediterranean waters through sustained application of superior resources and systematic operational excellence. The intelligence officers who debriefed the captured German personnel from U-377 gained valuable insights into German defensive psychology and tactical assumptions that proved critical during subsequent Allied operations. The German officers expressed genuine surprise at American tactical competence and technological capability, acknowledging that their preconceived notions about American naval inexperience had been fundamentally incorrect. This psychological victory proved as significant as the tactical success, as German military planning throughout the remainder of the war had to account for American naval competence that exceeded previous estimates. The success of the USS Woolsey in hunting and destroying U-377 demonstrated that American naval forces had achieved the professional competence and technological sophistication necessary for global maritime operations that would continue throughout the Pacific Campaign, and ultimately contribute to Allied victory through systematic application of industrial superiority and operational excellence. The Mediterranean had become the testing ground where American naval forces proved their capability to compete successfully against experienced European naval powers through superior organization, technological innovation, and sustained operational effectiveness. History isn't just written, it's remembered through those who still care to listen. The echo of that final sonar ping still resonates across the waters where American industrial might first proved itself against European naval tradition. What story should we tell next? Subscribe to keep their memory alive. Your feedback is incredibly valuable and helps me keep making better content for you.